Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on August 29th, 2025, which was about 3 days ago. The big takeaway is a lightweight method called MENTAT that boosts performance on Reasoning-Intensive Regression, with up to 65% improvement over baselines in key settings. The paper is titled Reasoning-Intensive Regression, and as we will see later, the implications for model training are quite significant. In short, it defines text-to-number tasks that demand step-by-step reasoning, shows why common fine-tuning, or plain prompting struggle, and introduces a hybrid prompt plus small neural aggregator approach that delivers calibrated continuous scores from limited data. On X, one post explains that models can reason through complex problems, yet struggle to output precise numbers, introducing reasoning-intensive regression and highlighting MENTAT as a fix. The example mentions estimating the fraction of a math solution correct. Engagement looks modest at 77 likes and 2 replies. The previous segment set up why lightweight methods often miss precise scoring. Figure 1 contrasts 3 approaches on detecting the first math error. The left panel shows fine-tuning NeoBERT, which collapses to near-mean predictions, so concordance correlation is almost 0. The middle panel shows detailed prompting for GPT-5, which ranks reasonably but quantizes outputs into bands, hurting precision. The right panel shows MENTAT with GPT-5, which aligns predictions along the diagonal, indicating better calibration and lower normalized mean squared error. The previous figure contrasted model behaviors. Figure 3 now shows how the target scores are distributed across the 3 tasks, which matters because calibration depends on matching these shapes. The left panel is broad from 0 to 10, reflecting how many steps a math solution stays correct. The middle panel clusters near 0 on a -2 to 2 scale, indicating paired RAG answers are usually close. The right panel forms a tight spike around 3 on a 1 to 5 scale, so essay grading concentrates in the middle. So the previous figure summarized score distributions. Figure 2 maps regression tasks into 3 complexity levels, which clarifies why some methods falter. Level 1 shows feature-based prediction, like house prices, where simple inputs suffice. Level 2 illustrates semantic analysis such as essay grading, where pre-trained encoders do well. Level 3 highlights reasoning-intensive cases, like detecting the first math error and pairwise RAG comparison, which demands stepwise deduction and calibrated scoring. Alright, the previous figure classified task complexity. Figure 4 lays out the MENTAT pipeline, which couples prompt evolution with multi-rollout aggregation, so the system reasons well and still outputs precise numbers. The left pink panel shows phase 1, where the model iteratively evaluates prompts, collects worst errors, performs error analysis, and picks the best prompt by validation normalized mean squared error. The right blue panel shows phase 2, where that prompt generates several stochastic rollouts per input, and a small neural regressor learns from sorted rollouts using a combined concordance and normalized mean squared error loss. The yellow box indicates test time, where processed rollouts feed the trained aggregator for the final score. Okay, the previous figure outlined the pipeline. Table 1 reports outcomes across tasks using normalized mean squared error and concordance correlation. The table shows MENTAT with GPT-5 delivered the best balance, with lowest error and highest agreement on math errors, while detailed prompting lagged because outputs were quantized. Pairwise RAG results highlight model differences, since GPT 4.1 sometimes matched or beat GPT-5. The ablations confirm both prompt evolution and neural aggregation matter, since averaging alone trailed the full method. Alright, 2 takeaways stand out. Reasoning-intensive regression needs step-by-step analysis, plus precise numeric calibration, and lightweight defaults like small encoder fine-tuning or plain prompting often miss both. MENTAT shows a practical path by evolving prompts and learning a tiny aggregator, suggesting hybrid systems can bridge reasoning and calibration. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.